For over a century, one weapon ruled supreme: the aircraft carrier. 5 acres of sovereign territory that could appear anywhere on Earth within weeks. Nations spent billions to build them. Entire strategies revolved around them. But what happens when the carrier never touches water, never lands, and operates where no defense can reach it? In February 2026, China unveiled something that shouldn't exist: a 120,000-ton warship capable of parking itself above any nation on Earth, deploying 88 autonomous fighters, from an altitude where missiles can't reach, where fighters can't climb, where sovereignty becomes negotiable. The broadcast lasted minutes. The implications will last decades. On China Central Television, a seemingly routine special on advanced UAVs suddenly showcased something no one expected: a computer-generated behemoth, a vast gray triangular craft floating above Earth's clouds, flanked by sleek autonomous fighters, deploying from internal bays. 242 meters long, 684 meters wide, 120,000 tons. To put that in perspective, it's as heavy as a nuclear supercarrier, but with a wingspan 7 times larger than the biggest aircraft ever built. Its name? Luan Niao, the mythical rock bird, a creature from legend that could carry mountains. This is China's version. And it's not carrying mountains, it's carrying 88 stealth fighters and a message. Within hours, defense circles erupted. Was this real? A propaganda stunt? Or a glimpse of China's actual roadmap? The answer turns out to be all three. Because what China revealed wasn't just a concept, it was a declaration. The Luan Niao is the centerpiece of something much larger: the Nantianmen Project, South Heavenly Gate, a mega-program to integrate aerospace and defense into a single, unified vision of future war. They'd already unveiled pieces: the BiD White Emperor 6th-generation fighter, a full-scale mock-up displayed proudly at Zhuhai. The Xuan Nu unmanned fighters. But the Luan Niao? This was the mothership, the crown jewel, the platform that would command them all. Chinese officials were candid about the timeline: 20 to 30 years of development needed, which meant this wasn't operational tomorrow, but it wasn't fantasy either. As one Chinese military spokesman put it, this is strategic early warning. The world should know where China is headed. And where China is headed is up. To understand why this matters, you need to understand altitude. Commercial jets cruise at 10 kilometers. Fighter jets can push to 20, maybe 25. Surface-to-air missiles? 30 kilometers, tops. But the Luan Niao is designed to operate at 100 kilometers, the edge of space. Look at that gap. That's not just altitude, that's invulnerability. Every weapon we've built to defend ourselves, surface-to-air missiles, interceptor aircraft, ship-based defenses, they all share one fatal limitation: gravity. They can only go so high. The Luan Niao operates where that equation breaks, where the air is too thin for jet engines, where missiles exhaust their fuel and tumble back to Earth, where traditional warfare simply stops. But its weapons, they come straight down, riding gravity like a highway, accelerating to hypersonic speeds, arriving in minutes. It's a one-way fight. They can shoot down. You can't shoot up. From 100 kilometers, sensors can see 1,000 kilometers in every direction. One carrier could surveil an area the size of Greenland. And it's above the weather, above the clouds, in perpetual sunlight. As one Australian defense expert put it, You're out of range of the weather, out of range of most defensive systems. You're essentially untouchable from below. As one Chinese strategist wrote, this is warfare reaching the high frontier. For centuries, militaries fought for the high ground, hills, mountains, altitude advantage, and dogfights. But this is the ultimate high ground, and it changes everything. Let's talk about scale, because the numbers are almost incomprehensible. 242 meters long, 684 meters wide. That's 7 football fields end to end, 2 Empire State Buildings laid flat, 120,000 tons, the same weight as America's largest nuclear carrier, except this one flies. Let that sink in. Everything we know about aeronautics says this shouldn't be possible. The square-cube law, the tyranny of the rocket equation, the limits of material science. By every conventional metric, the Luan Niao is impossible. To lift 120,000 tons into space would require staggering resources. The International Space Station is only 420 tons, and that took decades and dozens of launches to assemble. The Luan Niao is 285 times heavier. Which leads to the question, how? Chinese experts have proposed several approaches: modular construction in orbit, pieces launched separately, assembled in space, or advanced propulsion systems we're only beginning to theorize, electromagnetic launch rails, plasma thrusters, nuclear pulse propulsion, technologies that exist only in laboratories or don't exist at all yet. One Chinese official called it a distant fantasy. One Western analyst said it looks more like a Star Wars starship than anything we could build in the 2020s. But Chinese state media pushed back. We are violently challenging what the world thinks is feasible. And history has a way of proving skeptics wrong. Landing on the moon was impossible, until it wasn't. Stealth aircraft were fantasy, until they weren't. Rockets landing themselves? Science fiction, until today. The question isn't whether it's impossible now. The question is, how long does impossible last? 20 years? 30? And what becomes possible when a nation decides it must be done? The biggest challenge isn't size. It's simpler than that. How do you make it stay up? At 100 kilometers altitude, there's barely any air. You're in 0.1% of Earth's atmosphere. Conventional jet engines? Useless. They need air to breathe. Rockets work in vacuum, but the fuel required to hover 120,000 tons? You'd burn through it in hours, maybe minutes. So conventional propulsion is out, which means China needs something unconventional. Chinese sources mention induced force field drives. Force fields. Now, before you dismiss that, magneto-hydrodynamic propulsion is real. Plasma propulsion is real. Ion drives are real. They're just small. Scaling them up to move 120,000 tons? That's the leap. Chinese experts point to fusion reactors as the key, not fission, fusion. The difference in power output is orders of magnitude. One fusion reactor could theoretically generate power for an entire city, or one orbital carrier. China recently achieved a major fusion milestone. Their artificial sun sustained fusion for over 1,000 seconds. It's still experimental, still decades from practical use, but the timeline matches: 20 to 30 years for the carrier, 20 to 30 years for fusion power. Not a coincidence. The Bai-D fighter, part of the same program, uses experimental combined cycle engines, jet mode in atmosphere, rocket mode in space. One engine, 2 modes. Scale that up, add fusion power, and suddenly you have sustained flight. Is it possible? Not yet. But ask a different question. If fusion works by 2045, if combined cycle engines mature, if materials science solves the heat problem, then what? Then impossible becomes inevitable. The carrier itself isn't the weapon. The swarm is. Xuan Nu, the Dark Maiden, 88 autonomous stealth fighters, each one a sixth-generation aircraft, each one capable of independent operation, each one expendable. No pilot to risk, no life support systems, no hesitation. Western fighters carry pilots. That means weight, oxygen, ejection seats, G-force limits. A human pilot adds roughly 30% to the aircraft's weight and complexity. The Xuan Nu has none of that, which means more weapons, more fuel, more sensors, and maneuvers that would turn a pilot into paste. But the real revolution isn't the individual drone, it's what happens when you network them. 88 minds, one consciousness. They don't just fly together, they think together. Imagine this scenario: a carrier battle group in the South China Sea, protected by AEGIS destroyers, fighter patrols overhead, the most sophisticated air defense network ever created. Then, from 100 kilometers up, the swarm deploys. They don't attack as a wave, they orchestrate. 20 drones create radar clutter from one direction, drawing defenses east, while 40 attack from the west. AEGIS fires, shoots down 20 drones, then 40, then 60, but there were 88, and each drone carried 4 missiles. Do the math. The carrier battle group's defenses are overwhelmed, and the Luan Niao never saw any of it, never could be targeted, never could be threatened, and it just launches another wave. This is saturation warfare. The enabling technology is artificial intelligence. Each drone has autonomous decision-making, but the swarm shares information instantly. One drone spots a target, all 88 know in milliseconds. One drone is destroyed, the swarm adapts its formation instantly. It's not artificial intelligence, it's swarm intelligence, like starlings in a murmuration, thousands of individuals, 0 collisions, perfect coordination. Now weaponize that. China calls this intelligentized warfare, the next evolution beyond mechanized, beyond information warfare. Wars fought not by soldiers, but by algorithms. And the Luan Niao? It's the hive queen, the command node, the untouchable coordinator. So what does China actually do with this? First, consider the mobility. A traditional carrier battle group takes weeks to reposition, 3 weeks from the east coast to the Taiwan Strait. The Luan Niao, 6 hours, maybe less. And once it's there, it can see everything within 1,000 kilometers, every ship, every aircraft, every missile battery, multiple sensor types, fused data, perfect battlefield awareness. Consider the Taiwan scenario. Taiwan has sophisticated air defenses, F-16s, SAM batteries, early warning systems, but look at their range, 20 to 30 kilometers maximum. The Luan Niao sits at 100. Taiwan can't touch it, can't shoot it down, not even threaten it. But the Luan Niao can deploy drones that hit Taiwanese targets in minutes. Airfields, command centers, air defense radar. Each target eliminated before defenses can respond. First strike decapitation, before the shooting war even begins. Or consider the South China Sea. A U.S. carrier group operates there, protected by hundreds of miles of defensive perimeter. The Luan Niao appears directly overhead. Every defensive system on that carrier is designed for horizontal threats, cruise missiles from ships, aircraft from distant bases, but a threat from straight up. AEGIS can't elevate to 90 degrees. Fighter patrols can't climb to 100 kilometers, and hypersonic weapons falling from that altitude arrive in 4 minutes. No time to evade, no time to coordinate, no time to respond. As one Chinese analyst wrote, Aegis and carrier battle groups would be rendered useless. The opponent would have no way to defend and no way to strike back. But it's not just military targets. Position a Luan Niao above any capital city, and you have perfect surveillance, perfect targeting, perfect psychological pressure. The shadow of the carrier falls on the city below. Imagine waking up, looking at satellite feeds, and seeing this above your city, hovering, watching, waiting. You can't shoot it down. Your government can't make it leave. It's in international space, technically legal, but everyone knows it's armed. Now imagine 3 of them, 5, 10, distributed globally, covering every region, every flashpoint, every rival capital. This isn't just a weapon system, it's a new form of deterrence. For 70 years, deterrence meant one thing: nuclear weapons. Mutually assured destruction. You can't win a nuclear war, so nobody fights one. It worked. But it only worked because both sides believed it. Now China is introducing a new form of deterrence, not nuclear, but possibly more effective. Because here's the strategic trap. The United States has built its deterrence on forward presence. Bases in Japan, South Korea, Guam, the Philippines, carrier battle groups prowling the Pacific. Cost? Hundreds of billions per year. One orbital carrier makes all of that negotiable. Because if China can position a carrier above any of those bases, they're all at risk. So what does the Pentagon do? Build orbital interceptors? $500 billion. Develop space-based lasers? Hundreds of billions more for technology that doesn't exist yet. Build their own orbital carriers? Unknown cost, unknown timeline, unknown feasibility. Every option costs a fortune. Every option takes decades. Every option diverts resources from other priorities. And that's exactly the point. Classic deterrence theory. Force the adversary to invest in countering a possible threat. The Soviets faced this in the 1980s. Reagan's Strategic Defense Initiative, Star Wars, space-based lasers to shoot down ICBMs. Was it real? Was it feasible? Turned out, no. But the Soviets spent billions trying to counter it anyway, bleeding their economy, accelerating their collapse. Now China is playing the same game with one critical difference. Star Wars was mostly bluff. China's aerospace program is real. They've already proven hypersonic glide vehicles. They're building space stations, testing reusable rockets. The pieces exist. The physics work. The timeline is aggressive but plausible. So the United States can't dismiss this. They have to take it seriously. They have to respond. They have to spend. Which means China has already won the first round without building a single carrier. And domestically, the reaction was euphoric. Chinese social media exploded. Applications to engineering programs surged. Pride, confidence, a public convinced of inevitable technological triumph, and a wary adversary contemplating China's asymmetric moves. That's deterrence in the 21st century, not just preventing war, but winning the peace through the threat of overwhelming advantage. China doesn't need to use the Luan Niao, they just need you to believe they could. In 1914, aircraft were curiosities, fragile, unarmed, used only for scouting. By 1944, they ruled the battlefield. Whoever controlled the skies controlled the war. By 1950, jet fighters. By 1970, precision bombing. By 1991, air supremacy meant the war was over before it began. Today, stealth, drones, hypersonics. Every decade, the battlefield moves faster, higher, further. And now it's moving into space. This is the future China is betting on, not one carrier, a fleet. Not just military platforms, an entire ecosystem. Carriers, drones, fighters, satellites, ground stations, all networked, all autonomous, all coordinated by AI. War today still involves humans in the loop, pilots flying, commanders deciding, humans pulling the trigger. But in China's vision, algorithms make the tactical decisions. Humans set strategic objectives. Machines execute them. Warfare at the speed of computation, not the speed of human thought. A human pilot takes 250 milliseconds to react. An AI takes 1 millisecond. You can't train a human to be faster, but you can train an AI. This is what China calls intelligentized warfare, the third revolution in military affairs. After mechanization, after information warfare, intelligence warfare. China is making ready, investing billions, training thousands of engineers, building the foundations, not for today, for 2045, 2050, the next generation's war. And the United States? They're not sitting idle. Classified programs, black budgets, counter systems. It's a race, not to the moon, not to Mars, to the high frontier, to the ultimate high ground. And it's not just two players, Russia, India, Europe, all developing similar capabilities. The orbital space is becoming crowded, which raises the question nobody wants to answer. What happens when space becomes a battlefield? One destroyed satellite creates debris. Debris destroys more satellites. Chain reaction. Space becomes unusable for anyone. GPS fails. Communications collapse. Modern civilization pauses. The stakes have never been higher. China's orbital carrier is more than a weapon. It's a symbol of ambition, of how far nations will go for advantage, of a future where the battlefield has no ceiling. For a century, aircraft carriers ruled the oceans. Now, they may rule the sky. The question is, are we ready for what comes next? The race for the high frontier has begun.